So most of what we did in the previous lessons in this unit, not everything, but most of what we did, and especially 4.3, was to help us find trig ratios of certain angles, okay, without the use of a calculator. So putting this all together, remember the unit circle equation is the x coordinate squared on the unit circle plus the y coordinate squared on the unit circle will always equal 1. And you can see it here, because if we did Pythagoras, this squared plus this squared must equal 1 squared, which is 1. Okay, now we can actually apply some trig. What's the ratio for cosine? When we did trig ratios, it was always a ratio of one side of a right triangle over another. Opposite over hypotenuse for cosine? Remember Tokatoa? Yeah. No. Taking a deep breath. Adjacent over hypotenuse. Well, on the unit circle triangle, what side is labeled the adjacent? What side is the hypotenuse? So isn't the cosine of the angle just whatever the x coordinate is of the unit circle? To find the sine of an angle, opposite over hypotenuse. Well, the opposite side on this unit circle here, or this triangle on the unit circle, is y. The hypotenuse is still 1, so the sine of the angle will simply be the y coordinate. And the tan, opposite over adjacent, which means the y value, whatever this y length is, or the y coordinate in the unit circle, divided by the x coordinate on the unit circle. So that one we got to do a little work for. So whenever you have a point on the unit circle, the cosine of its corresponding angle will always be the x coordinate. So the x coordinate of a point on the unit circle will be the cosine of the angle that goes through that. And the sine of the angle will be the y coordinate of that point. So like if I gave you this on the unit circle, and if I said, okay, this is this angle here is pi over 4. What's the point on the unit circle with pi over 4? Root 2 over 2, comma root 2 over 2. Therefore, we can find the trig ratios. The cosine first. Cosine of pi over 4 is the x coordinate of the point on the unit circle. So it's root 2 over 2. The sine of the angle pi over 4 is the y coordinate of the point that y over 4 goes, or pi over 4 goes through. Same thing. And the tan of pi over 4 will be the y value, root 2 over 2, divided by the x value, which is also root 2 over 2, and anything divided itself is 1. So that's how we can find a whole bunch of trig ratios of common angles, 30 degrees, or the pi by 6s. 45 degrees, or the pi by 4s. Or 60 degrees, or the pi by 3s. Or 90 degrees, which are the pi by 2s. Okay? This is actually a review from last year. We did this last year with degrees. Okay. Speaking of the three trig ratios, well, we set up top, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tan is opposite over adjacent. What happens if we flip them all? If we flip them all, we get three new trig ratios. These are what's called the three primary ones. These are the ones we use most often. Okay, but we can use the other ones. When you flip sine, so instead of opposite over hypotenuse, it's hypotenuse over opposite. You get a new trig ratio, shorthand CSC. Which stands for cosecant. If you flip the cosine ratio, hypotenuse over opposite, or adjacent, pardon me, you get a new trig ratio. Shorthand is SEC. That is short for secant. And if you flip tan, so make it adjacent over opposite, you get something called COT, which is short for cotangent. How do you remember these? Well, the way that I remember, like tan and cotangent are pretty easy to remember because they both have the word tangent in it. So what's the reciprocal of tangent? Cotangent. What's the reciprocal of cotangent? Tangent. The way that I remember these ones is I look at the first letters. If it's sine, the reciprocal begins with C. If it's F, it begins with C. If it's C, it begins with S. Kind of reverses. So when I think of sine, well, its reciprocal must begin with C, and that's cosecant. If I think of cosine, its reciprocal must begin with S, that's secant. That's just the way I do. Okay. So on to some examples. So here, these ones, remember, we can find all the trig ratios if we have a right triangle. So we want to make a right triangle on a coordinate grid. So the point -3/5, -4/5 lies at the intersection of the unit circle and some angle. I don't know what it is. Draw a diagram to show this situation. Find the 6 trig ratios. What quadrant? So -3/5, 4/5 is going to be somewhere on the circle. Where? What quadrant? Quadrant 3. And remember, I'm only sketching, so I'm just going to put it here. And how do I make a right triangle? Well, first of all, from the point on the unit circle, I always draw a vertical line segment. My hypotenuse always comes from the origin. And then that finishes the right triangle. And so this is theta here, from here to here, but this is the reference triangle I'm using. So this is the point, negative 3/5, comma negative 4/5. And remember, it's on the unit circle. What's this length? 1. Okay? This length, remember, the first is the x coordinate, and the second is the y coordinate. So now that I've got all three sides, I can do all 6 ratios. Let's do the ones we're familiar with. Cosine, which is adjacent over hypotenuse. What's the adjacent side? Remember, this is our angle here. What's the adjacent side? This one here, right? Because this is the opposite side. 1 is always going to be the hypotenuse. So it's going to be negative 3/5 over 1, right? Which is just negative 3/5. But I know that the cos is always the x coordinate. The sine is always the y coordinate. So without having to do all this stuff, I can just go straight to this. What's the tan? Yes, or the y divided by the x, right? So the y value is negative 4/5, and I have to divide the x value, which is negative 3/5. So remember, change this to multiplication, negative 4/5 times negative 5/3. The 5's reduced down to 1. I get a negative times a negative, which is positive. 4/3. Notice I get those 3 first, because then the other 3, you just flip them all. That's it. So, what's secant? Yeah, so which one? I got to take which one and flip it. I don't even have to do that. Isn't it the reciprocal of this? Right? CS. So flip this. Negative 5/3. Cosecant. Negative 5/4. Cotangent. 3/4. So you just find the 3 primary ones, and then to get the 3 reciprocal ones, you just flip them. Okay. The next one. Remember, you're given a question like this, where it tells you quadrants or it gives you a point on the unit circle. Always do a diagram. It really helps. Okay? So I've told one of the ratios, cotangent. I'm told that if I draw it out, a triangle out on the unit circle, my triangle is going to be in quadrant 2. So how do I draw a right triangle in quadrant 2? First of all, your hypotenuse always comes out from the origin. Then a vertical side, and one of your horizontal side is always one of the x-axes, positive or negative. To find the ratios, I need to know all the sides, right? So, cotangent is what side over what side? Give me the sides, adjacent, opposite. Adjacent. Adjacent over opposite. So doesn't that mean that this 12 must be the adjacent? And this 5 must be the opposite. The question is, where does the negative go? Does it go to the 12 or does it go to the 5? It can't go to both. Okay? Remember, we're in this quadrant. This is the opposite, right? Positive or negative? This is positive, so this must be 12. This is negative, so the negative must go to the 5. What's that? Oh, wait, did I get it? No, sorry. I got my numbers wrong. I got my negative right, but I got my numbers wrong. So it should be negative 12, positive 5, like that. To get all the trig ratios, I need all 3 sides. How am I going to find this side? A squared plus b squared equals c squared. It's not 1 because we're not told it's on the unit circle. So I'm going to have to do 5 squared plus, and always put negatives in parentheses, because when you square negatives, they're always going to become positive. And remember, we called, I want to use R. I mean, if you call it C, it's still fine. So 5 squared is 25. This is 144. So 169 is equal to R squared. Therefore, R squared is going to be be careful, plus minus square root of 169. The question is the answer going to be plus or minus? Because the hypotenuse is always plus. So we're going to ignore the minus. R is going to be the positive square root of 169, which is 13. Okay? If you were to find this side by Pythagoras, it would have to be negative. This side would have to be positive. If you found this vertical side down here, it'd have to be negative. So you got to watch out for that. Yeah. Oh, sorry. R is equal to, yeah, thank you. Good catch. Okay, so now I got all the sides. So sine. Opposite over hypotenuse. Give you the numbers from the triangle we just made. 5 over 13. Cosine. Negative 12 over 13. Tan. Five over negative 12. Or just negative 5/12. Either one's fine. Notice that makes sense, doesn't it? Because isn't this also, if I flip this, it becomes tan? So it makes sense. The only other two, secant, or sorry, cosecant. Flip sine. Secant. Flip cos. And we're done. So when you're asked to find trig ratios and you're given a quadrant or a point on the unit circle, okay, or a point in a quadrant, doesn't necessarily have to be in the unit circle. This is where you're going to have to use Pythagoras. And remember to draw your right triangles correctly. Never, ever draw a right triangle on a coordinate grid that has the y-axis as the side. Never. Remember, the hypotenuse always has to come out from the middle. All right. We're going to scrap this one. We don't need to worry about this. Last thing you want to do with this is we want to be able to find a whole bunch of trig ratios of common angles without using a calculator. So let's start with this one, the 30 degrees now. What is 30 degrees in radians? Pi over 6. What's the point on the unit circle? 3 over 2, 1. Cos will always be the x, root 3 over 2. Sine will always be the y. Tan will always be the y divided the x, or the y times the reciprocal of x. 1 over root 3, and you can leave it like that. You don't have to change it so there's no radical in the denominator. You can leave it like that. The next family is 45 degrees, which is how much in radians? 4. Root 2 over 2. Root 2 over 2. Therefore, both cosine and sine will be root 2 over 2. And this one is just going to work out to 1 because root 2 over 2 divide root 2 over 2. Anything divided itself is 1. The 60-degree family, or in radians, pi over 3. The point on the unit circle, 1/2 on the root 3 over 2. Therefore, the cosine is 1/2. The sine is root 3 over 2. And the tan is root 3 over 2 divide 1/2, or root 3 over 2 times 2 over 1, which works out to exactly root 3. Okay? Going to do a little bit more here, and then we'll finish the rest next time. So these ones, the 90-degree family, actually starts at 0 or 360 degrees. Those are both the same. Then it's 90. Then it's 180. Then it's 270. Oh, sorry, I did make room for 360. I didn't think I did. 0 degrees and 360. These are the ones where the numbers on the unit circle are going to be 1 or 0 or -1. 0 degrees in radians. 90. Pi over 2. 180. Circle. 1 pi. 270. 3 pi over 2, and a complete circle gives us 2 pi. The point on the unit circle at 0. 1, 0, which means it's the same as 360. Everything's going to be the same. So the cosine is 1. The sine is 0. And the tan is 0 divided by 1, which is 0. And it's going to be the same thing here. Because 360 is just coterminal to 0. What's the point on the unit circle at 90?
0,
0, 1. So therefore, cos is 0 of 90 or pi over 2. Sine of 90 of pi over 2 is 1. And the tan is 1 divided 0. Undefined. We cannot divide by 0. And if you did that on your calculator, if you did the tan of 90, you'll get an error because you can't do it. What's the point on the unit circle of 180?
-1.
-1, 0. Therefore, the cos is -1. The sine is 0. And the tan is 0 divided -1, which goes back to 0. Forgot the where? -1 where?
0, 0.
Thank you. This one is 0, -1. Therefore, the cos of 270 or 3 pi over 2 is 0. The sine is -1. And the tan, once again, is -1 divided 0, which we can't do. So it is undefined. And we can use all these to find angles in the other 3 quadrants. So let's just start with a few. And now this is sort of the big part. Now we're going to actually start evaluating some of these. So here's what I do. Okay. When I'm asked the sine or cos or tan, or it could be one of the reciprocals, okay? First of all, I want to determine, am I reading the x coordinate on the unit circle, the y coordinate, or the y divided the x? This tells me I'm going to read the y coordinate of this point on the unit circle. So I take those things and piece them apart. So I got to find the y coordinate. Sorry, I got to find the point on the unit circle at 7 pi over 6, and the y coordinate's my answer. So where's 7 pi over 6? You might want to just sketch this to help you. Well, the pi over 6s are the ones that are close to the x-axis. This one's here. So it's -√3 over 2, comma, -0.5, right? What's the y coordinate? Here. And that's my answer. You'll find that, it may help you to do this first. Or if you get stuck, a lot of you are able to sort of visualize the unit circle. Okay, this one tells me y coordinate of 7 pi over 4 on the unit circle. 7 pi over 4. It's here, right? So it's √2 over 2, comma, -√2 over 2. But I want the y coordinate. So it's -√2 over 2. Try the next one. You should be able to do the next one. What do you think? √3 over 2. Okay. So this tells me x coordinate. 330 degrees is here. And the x coordinate is the longer or higher value, √3 over 2. This one, I got to do some work. Because it's not just the x, it's not just the y, it's the y divided the x. So I got to find 2 pi over 3, the point, and divide the y by the x. Well, 2 pi over 3. The pi over 3s are the high ones and the low ones. The ones that are close to the y-axis. Where's 2 pi over 3? What quadrant? And it's high. What's that one? That's the short distance, -1/2. √3 over 2. So therefore, I got to go √3 over 2 divided by -1/2, which is the same as √3 over 2 times -2 over 1. The 2's cancel each other out, top and bottom. And I am left with just plain old -√3. Okay. Let's have a look at these two. And then I think we'll stop after this. Oh, what do I do with this? I can't read cosecant on the unit circle. Can I? I can read cosine. I can read sine, like cosine's the x, sine's the y. I can read, or I can calculate tan by doing the y divided the x. How do I do this?
It's one. So sine is y.
How about if I find this and flip that answer, right? Because the reciprocal of this is sine. So I find that one, and then I just flip it to get cosecant. Good, well done. Well, the sine of pi over 3, that's y. It's up here. So that's √3 over 2. And remember a flip. So my final answer is 2 over √3. So when you get one of the reciprocal ones, find its reciprocal and then flip it back. Oh, this one's, what are we going to do with this one? Okay, we're going to make a cos of -pi over 6. Find that answer and then flip it. How do I do -pi over 6? Not flipping it. This is not an angle that's in the unit circle, is it? Right. I need to make it a positive angle by adding 2 pi, or as a fraction over 6, 12 pi over 6. So that means it's going to be the same as cos 11 pi over 6. And reminding myself I got to flip it. So cosine 11 pi over 6. Well, 11 pi over 6 is here. Cosine is x. That's the higher value, so it's got to be √3 over 2. And flip. Once again, it works out to 2 over √3. Last thing I want to finish with, that I won't do until next class, is what happens, like really, I mean, the next example is pretty straightforward too, but you're going to be expected to know ones like this, where you have to ask, where you have to find a few of them and then combine them in some way by adding, subtracting, and multiplying. It's not that bad. You just find them separately and then do the operations. Okay. But we'll save that for next class because I think we've covered enough today. This is a pretty long one.